Good morning, student. Today, once again, we are here to study another important aspect of physics, and that is heating effect of electric current. Student, by the name itself, heating effect. As you know about the heat energy is generated. Where it is generated? Across the appliances which we are using. Student, heat is generated everywhere. Student, whenever there is a current. But the difference is in some cases the heat generated is of very much higher energy which we are using, say electrical press, toaster, many things like this. Many appliances like this we are using it. So today we have to understand the basic concept of this heating effect. The electricity is flowing and how it is heated. Okay. So for this I have taken a very simple circuit, a battery or a cell I can say, voltage V. This is a student conductor. So if this is plus, this V, it will come here, same volts. This point and this, they will be at same potential. This is a resistor. There is a potential difference. So how much is the difference, student? V. As it is directly connected. Now suppose, student, a charge Q flows through resistor in t second. Okay, student. Now how this charge will flow? Work has to be done, student. To make movement, work has to be done, energy has to be delivered. Who is doing this work? This battery. Battery is doing that work. Okay, student. Since I am using the word battery, you should not get confused. So I have used one more cell. This whole is a battery, student. Now, student, to make the charge flow Q across a potential difference V, how much is the work done? I am coming to the basic. What is the meaning of V? Meaning of V is work done to carry 1 coulomb charge. That is the meaning. Now, for 1 coulomb charge, work done is how much, student? V. This is the meaning of V. Therefore, for carrying Q coulomb of charge, work done will be, this term you have to understand, student, QV. I am writing it here. Now, student, this charge is equivalent to the current. Say current, now I am writing I. Now the relation. This charge flows for t second. We already know, student, Q is given by IT. I is the current. So this work done by the battery is QV, student, and this I can write as VIT. Now, student, work done is energy. This already you know it. Now, since battery is doing work, so energy of the battery is consumed. Energy of the battery is consumed. From where does the energy is coming in the battery? Due to chemical reaction. Okay, student. Now, student, according to law of conservation of energy, according to law of conservation of energy. Energy cannot be destroyed. So this energy which is consumed, where it has gone? This energy has converted, I can say, chemical energy has been converted into heat energy, student. It has been converted into heat energy. So now I have a formula of heat energy. VIT, another formula QV. So student, this is the formula for heat which is generated across the device where the electricity is flowing. And here the device is, or the appliance is, resistor. Now student, I will explain you the depth meaning of this QV. The formula for heat energy which I am getting is VIT. Now student, from Ohm's law. What is Ohm's law, student? V is equal to IR. Substitute IR here, I will get here I am using small letter I, student. Here I have written capital I, so I am writing it small I only, student. Okay. Now student, another formula of heat energy is I square RT. Now from here student, we get I is equal to V by R. Again I can write another formula here. I have substituted from here. This means, student, an electrical appliance which has resistance R. Electrical appliance which has resistance R. In that, when current I flows, this much is the heat energy generated. And that heat energy depends on which factors? Time, resistance and current. Now what I want to say is, student, this term, remember student, resistance. It is the name of a property of obstruction. Why it obstructs? The basic cause. The basic cause is, student, collisions. This you have to remember. When electron is traveling, it is colliding with the ions, with the atoms. During that collision, it transfers its energy to the atoms. And it is that energy which is converted into heat energy, student. All are pushing each other, all are repelling each other. In this pushing, there is a force which is exerted. And that force gives rise to work done due to the displacement, student. As if when you see the heater, we cannot see anything displaced. We can see heater that coil becomes red hot, but we cannot see anything displaced. But inside that coil, this is happening, student. Electrons, they are moving. Force is applied on other electrons. This force gives rise to work done, and that work done gives rise to energy, and that is heat energy, student. So this you have to remember, student, resistance. One more thing, student. This formula, V is equal to IR. Remember, if I made this V double, so by formula it appears this R will become double. No, student, in R there will be no change. Because R is the hardware. R will not change if I change this V. By formula it appears it will change. For example, student, if I say this is an electrical apparatus, say it is a bulb, it is having mass 500 gram, I say, okay. And now suppose I pass electricity through it and I am changing the voltage. Will that 500 gram will change? No. Because it is the hardware. 500 gram will remain 500. Similarly, as mass is a property, resistance also is a property of that substance. It will not change. If we want to change R, we have formula already learned. R will change due to these parameters, L, A, this. But due to this V, R will not change. And what is R? Property, resistance. It generates hits. Why it generates hits? Due to generate heat. Due to collisions, student. So when a current I passes through a resistance R, the heat which is generated is this much. This is also known as, student, Joules law of heating. So have you understood the meaning of R, student? R is the resistance of that electrical appliance which is connected. So student, we have various formulas for heat energy. See this formula V, it is only a voltage which is applied, VIT. This formula I square RT. So in this formula, though they are same, but this formula is actually specifying the reason behind that heat. So that is why the most important term, the formula utilizes this one. Though in other cases this will also be used. We will solve it through various numericals, student. Now student, heat generated formula we already have done. Heat generated in time t. Heat energy generated in time t, given by time t seconds, student. So how much is the heat generated in 1 second? See student, another formula we have. So what is this? Heat generated see, I have divided this by time, and this heat is the energy, student. This is work upon time, and this work upon time is also known as, student, power. Power it is rate at which heat is generated. So now we have a formula for power, I square R. This formula can be converted into various forms. I, you write V upon R. So you will get this formula. Means we are dividing this term by time. Here you divide by time, you will get another formula for power. So student, see these three terms. What they are telling? They are telling amount of energy, heat energy which is generated per second, per unit time, student. Now student, there is a confusion regarding these two formula. Here power is directly proportional to R. Here power is inversely proportional to R. But remember student, it is a mathematics. What you have to remember is this relation R, it is depending on which quantity is constant. If current I is constant, I am writing it here. If current I is constant, then power is proportional to R. But when voltage is constant, in that case power is this. Indirectly, though it is looking opposite, but they are same thing, student. We'll see it in numericals. They are saying the same fact. But while using the numerical part, you have to remember this relation. We'll solve it in various questions also. Okay, student? So now, student, we have formula for power also. VI I square RT, and also, student, V square by R. Now, student, let's see the unit of power. From the basic formula, heat generated upon time. Work upon time. And already you know SI unit of work is joule, time is second. This is given name as watt, student. So SI unit of power is watt. Now what is the meaning of 1 watt, student? 1 watt power means the energy consumed by the appliance or the devices is 1 joule in 1 second. This is the one meaning of power, student. There are two kinds of devices. In some devices power is delivered. In some devices power is absorbed. So we have different things. But basic meaning of power is this. Energy consumed, or it may be delivered also, okay? That will depend on the situation. But this is same, 1 joule 1 second. Say it is giving 1 joule energy 1 second. Say it is consuming 1 joule energy in 1 second. Then the power is 1 watt. We have a bigger unit of power, student, 1 kilowatt. This is known as 1000 watt. Let's, students, solve some question related to power. Suppose, student, we have, say, one formula I have derived. H is the heat, okay? Heat energy which is generated, student, okay? Suppose, student, there is a resistance. In this, a charge of this much coulomb has been flown for 2 hours. And say this voltage which is applied here is 100 volt. Okay, student? So question is, how much is the heat energy generated? Now which formula to be utilized? One formula already I know it, VIT student. This IT becomes I. So in this V is given 100 and if you multiply this, the energy which you will get is in Joule. One more thing student, the formula power is equal to V into I. From this we have another unit of power, this is volt ampere. Volt into ampere. Okay student, this is equivalent to joule per second. This is also what is 1 watt. When student we say that the power of a bulb is 100 watt. What is the meaning of this? This means bulb will consume 100 joule of energy per second. So this is all. This is actually not full data is not there. One voltage is also given student, that will come in another topic. Now I am just saying the meaning of this. Okay. When voltage will come with this, I will explain the meaning of that also. But now you just understand the basic meaning. 100 joule of energy per second the bulb is going to consume student. This is the meaning of 100 watt. Now to clarify the difference of the two formula student, one formula we got I square R. This formula actually confuses us many times student. To make it clear, I am solving one numerical student. Suppose I have two resistors, 1 ohm and 2 ohm. Here I connect a 6 volt battery student. Now the question is power consumed in 2 ohm resistor. Now what one mistake generally occurs is, here 6 volts, so student directly apply this formula. But remember student, this formula direct is not applicable here because this 6 is not available here. If I want to power off this, I have to find out voltage across this, and here 6 volt has been divided into two parts. So this 6 volt is not the voltage across this, so I cannot apply directly this formula. How to apply this formula or this thing student? First you find equivalent resistance. These two are in series. Same current will pass. R1 plus R. Okay student. Then you find out current. Current is V by R, 6, 2 ampere. Now student, I can apply this formula because current I got, same current will flow. Now I can apply this formula student. I am writing it here student after this. Power across 2 ohm. I square R. I got 2. R is also 2 student. So the answer is 8 watt. Now if I want to use this formula, student, I have to know the voltage across this. So how much is the voltage across this? Formula is I R2. I is 2 student, R2 is 2. 4. Now student, power. I am using this formula. Four square by 2. See student, again I am getting the same answer by both the formula. But you have to remember this 6 volt does not appear here. So student, today's homework is you have to solve these questions once again in your notebook. Once again you have to write it on your own understanding, and then you have to solve some extra questions related to this. Very soon there will be a test again which will be conducted based on this. Okay, that I will specify. Thank you students.